We will now introduce a small artificial population. I think it's clear that it's artificial, huh? It's definitely small. Our population, which we are going to denote by calligraphic P, consists of 4 units. Let's say 1, 2, 3, 4. And that means if we apply our recently developed terminology and notation, the units will be capital I, 1, 2, 3, 4, and the outcome variable, the survey variable, takes values 1, 2, 3, 4 also. They could have been 2, 4, 6, 8, but let's keep it simple for now. This is the enumeration of the units, and the population size n is equal to 4. Now, because of this very small population size, we are able, unlike in the Belgian Health Interview Survey, to enumerate. That would mean to list all units or all entities that have a certain property. For example, we could take all possible samples of size n is equal to 1, which means that this is the sample with unit 1 only, next the sample with unit 2 only, next the sample with unit 3, and finally the sample with unit 4. It looks pretty much like this is still equal to the previous population as a whole, but there is something fundamentally different. More than the curly braces, these are actual samples taken, yes, consisting of a single unit, but from here we will easily go to samples of size 2, 3, 4, and who knows, more. So we call this superpopulation, this synthetic population, the population of all possible samples. And this is really something you need to understand very well. It's not something that will pass by and go away. No, it's here to stay, and it plays a fundamental role in everything that's coming. So, because there are 4 such samples, we denote by S the number of samples of size 1, and calligraphic S, so these two S's are not the same. S is equal to 4 is the number of samples with a given property, namely being of size 1. Calligraphic S1 is this particular population of samples, and there are 4 units indicated by lowercase s. It becomes a little more clear if we turn to samples of size 2, because then you clearly see that this S2 is different from the population that we are actually considering. It's related to it, it follows from it, but these are all the possible samples of size 2. And you might intuitively think 4 choose 2, so 4 choose 2, that's equal to 6, right? But we see more than 6 samples. And even here we see more than 6 samples. So why is that? We should not forget that a priori it's also possible to have samples where the same unit is occurring more than once. Let's call that now heterogeneous versus homogeneous samples. Okay, so if we look at the enumeration and we just count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, well, it's actually 6, 12, and then plus 4 is 16, 16 samples. Yeah, but the samples 1, 2 and the samples 2, 1 come into being in a different way. In the first case, I sample 1 followed by 2, I should say. In the other sample, I sample 2 followed by 1, but in both cases, the net result is I have the units 1 and 2 in my database. The order may be different, but usually, not always, but usually that's not a problem. So, if we take ordering into account, we have 16, but if we don't, we only have 10 samples. 6 heterogeneous samples, which in this case can only mean that the 2 units are different, and 4 homogeneous samples, meaning that the 2 units are the same. So, again, calligraphic S is a population, a meta-population, a synthetic population that describes not just the population, it also describes the samples we are going to be able to take from it. Of course, we can define this any way we want. We could say all samples of sizes 1 or 2 that would be a very interesting exercise. Write it down what you mean by it. Enumerate for yourself all the samples of size 1 or 2 taken together. Of course, next I can consider samples of size 3. That's also a good exercise. Hey, what do we mean by that? There are only 2 units. Yeah, but we could say calligraphic S3 consists, for example, of 1, 1, 2, ... and it's a good exercise to enumerate those for yourself. Of course, you're not going to have fully heterogeneous samples here. It's not possible to have samples with all units different and of size 3. So, which means that if I forbid samples with more than 1 unit the same, 3 would not be possible. And that would actually be sampling without replacement. We will come to that. If you take a sample without replacement, the sample size must be smaller than the population size. But here is a case in point. If you allow at least some sampling with replacement, the sample size can be bigger than the population size. Okay. So, next, let's look at a few estimates. Characteristics of the population. We don't know those for the Belgian population unless we do a census. But here we can do a census. We create our classroom kind of population with then moreover only 4 units, so it's easy to calculate the population average. The average of 1, 2, 3, 4, that's equal to 2.5. The population variance, you take the formula for the variance and you calculate this quantity, 1.25. Oh yes. And there are people who may say, but you divide by 4, you should divide by 3. Correct when later we look at estimators. But because this is the population where everything is known and nothing needs to be estimated, we can just as well divide by 4. So 1.25. Population total is the sum of the 4 units, and that gives us 10, of course. Okay. That brings us to the end of the artificial population. In the next section, we will look at the third and last example. By these 3 examples, then, we will be well equipped to cycle through the rest of the course and illustrate whatever needs to be illustrated with what's available.